Hi everyone, this video is on exercise 9 out question 7. So we have this curve, and in the first part we want to find whether the gradient is positive, negative or 0 at each of the points. So we have basically 4 different points, A, B, C, D. Okay, so just to maybe go back to your GCSE knowledge, if we have a curve and obviously we don't have any equations and we want to see if the gradient is positive or negative at a specific points, the first thing that we should be thinking about is basically drawing tangent lines to those points, because those tangent lines are going to help us to find the gradient, or at least if we don't have any if we don't want to do anything analytically, at least we can see from the graph and just say that whether it's positive or negative. So in this case, so this can be a tangent to A, which is not the best. So let me try again. So a good tangent to A is something like this. It's hard to sketch from here and to be very accurate, but hopefully you get the idea. So this one didn't even intersect. So yeah, let's imagine this is a tangent to A. And then I'm going to do this for each of these points. Okay. So now we have the tangents, and we can clearly see from the straight lines that we have, just to realize the basically the sign of the gradient, right? Because if you look at the first line, the tangent line to point A, it's a straight line of this form, and hopefully you remember that if you have y x-axis and the straight line is like this, then that means the gradient is negative. So we can simply say the gradient at point A, or we can just write dy dx, is negative. Now at point B, let's see what we have at point B. So at point B, it's very clear that it's just a straight line, and it's neither going upwards or downwards. No, so what's happening here is that the gradient is actually 0 in this case. So point B, the gradient is 0. Now what about C? So C this time is of a similar form to this form. So if you again remember these types of graphs, straight line graphs, so that means C is basically has a positive gradient. And finally D, which my sketch isn't very accurate because it's meant to be a line that is just a straight, it's not going upwards or downwards. So it's basically similar to B, and again at point D the gradient is 0. So yeah, that's part basically the first part, by just simply using the fact that we can sketch the tangent line and then use that to determine the sign. Now for the second part is about the second derivative, and we want to see if it's positive or negative. So before I do the second part, let me quickly remind you some very useful facts about the second derivative in general. So the second derivative allows us to see if the curve is concave or convex. And for instance, in terms of I'm talking about this time the graphical behavior, because usually we just talk about the algebraic and just analytical behavior, but this time it's about the graph and geometrical behavior. So if the curve at a specific interval is concave, then you are going to have this sort of upside down U shape. So any variation of that shows concavity. And then for being convex, you have this basically U shape. So again, any variation of that implies the same thing. So this is crucial to solve this question, because that's exactly what we are going to use for this question. So we don't need these tangent lines anymore. Okay, so if you look at point A, as you can see, we have this U shape, this U shape, as you can see, any variation of that is valid for us. So since we have that U shape, then that means the graph at that point, the curve is actually convex. So, which means the gradient is positive. That's the second derivative is positive. So when the curve is convex, the second derivative is positive. When it's concave, it's negative. So for the second part, at point A, d squared y dx squared is positive because the curve is convex. Now what about B, point B? So point B is still the same thing. As you can see, this has this sort of U shape. So again, if you just look at here, that's similar to the bottom of that. So this is indeed positive, which means it's convex. Now C, so C is finally a concave one because this has the upside down U shape. If you continue that, so C is negative. D squared y dx squared is negative at C, and then finally D. So D is probably the interesting one in this case, and the reason is that maybe I need to change this slightly, is because D is the point of inflection, which means the second derivative is 0 at the point of inflection. Why? Because remember, point of inflection is a point that the curve changes from being concave to convex, or vice versa. So, and this is exactly what's happening, because the curve here at this, is continuing to be concave until it reaches B, and suddenly it changes direction such that it's no longer concave, and it's this time convex. So yeah, that's why D is the point of inflection, therefore the second derivative is 0 at D. Okay, that's it for this video, and thank you for watching.